So here we are discussing about magnetic quantum number. Next one is magnetic quantum number. Magnetic quantum number will explain us about the orientations of the subshell. If we take as orbital is nothing but a three-dimensional space where the probability of finding the electron is maximum is known as orbital. Where we take p subshell or orbital, we have three orientations, that is px, py, pz. These three axes, that means x, y, z, these three axes are perpendicular for each other. X is perpendicular for y and z, and y is perpendicular for x and z, and z is perpendicular for x and y. How can we find that p orbital contains three orientations? So for this we use ml. The magnetic quantum number is represented with ml, and to find the orientations we use the formula 2l plus 1 to find the magnetic quantum number or the orientations of the subshell. If we substitute the L values here, we'll get the number of orientations. So 2L plus 1, if we substitute L value is equal to 0, that means S subshell, it contains 2 into 0 is equals to 0, and 0 plus 1 will be 0. So S subshell will contain 1, that means 1 orientation. If we substitute L value is equals to 1, 2 multiplied with 1 will be 2, and that add up by 1 is equals to 3. So the orientations of P will be 3, px, py, pz, and d orbital, f orbital will have 5 and 7 orientations respectively. Where we come to shapes of the subshells. Shapes of the subshells, S subshell will be spherical in shape. So there is only one orientation, we represent it in spherical shape by involving three axes. And here we got p orbital. P orbital contains three orientations, we represented here. Px orbital will be on x-axis, and py will be on y-axis, pz will be on z-axis. These are the three orientations, and it is in dumbbell shape. So p orbital is dumbbell shaped. And here d orbital. D orbital contains 5 orientations, dxy. The orbitals or the dumbbells is double dumbbelled shape or clover leaf shape. So d orbital is double dumbbelled. So the lobes of the orbital will be placed inside x and y axis. Here x, here y, and the lobes are present in between those axes. And here dxz. So the lobes of the orbital will present in x and y, present between x and z orbitals. And here dyz. So this is the third orientation of the d orbital. Here the lobes of the orbital will present between z and y orbitals. So this is the fourth orientation of the d orbital. Here dx square y square means the lobes will present along the x-axis and y-axis. And the last and final fifth orientation of the d orbital is dx square. Here dz square. The two lobes or one orbital will be placed between z-axis or on the z-axis, along z-axis, and another x square means two orbitals. So another lobe will be revolved or placed around a circular path around z orbital. So these are the 5 orientations, and f subshell is very complex in nature, and these are we can see f orbitals in lanthanides and actinides series. So f orbitals diagram or the pictorially we can't, it's a very complex thing, so we can't represent it on pictorially. So this is about magnetic quantum number.